Fast housekeeping and preface. I try to make the slides worth downloading, and I welcome emails with constructive critique. Or stop me in the hallway. I love the hallway discussions, and I'm always interruptible. I want you to easily hear me, even from the back. If I lose volume, everybody signal me. Q&A is the last 10 minutes. I'm keen for your questions, but I can only take quick questions throughout. A single sentence question where you need something clarified, yes, please ask. We'll have no time for statements of disagreement or, but what about? And I'll know that you want to. My questions to you are for you to formulate answers in your head in about 10 seconds. Please do think of your answer. It helps the learning process. Hi, I'm Bruce Gray, UTL Online. I've been giving talks on Perl 6 for several years now. Pardon? Okay. Several years, Perl 6. And now I wanted to tackle something harder. Something that happens to transcend the particulars of most languages' syntax. This is not a Perl-specific talk. I get cheer from the back. Now, where I do use Perl 5 code, I don't want to take up space on every code slide. So I'll use the signatures added to Perl 5 years ago. So I can just write this. Last bit of preface. I gave this talk last week, and I shelved it and started over. I'd written it like an 8-hour class crammed into an hour, and nothing could be understood. I'm a year into a 5-year mission to improve this field, and the talk was terrible. So this talk is a calculated scattershot across the topic. I presented it at Southeast Linux Fest 3 days ago. Much better. You might want to watch their video to see the parts I'm skipping today, which made room for still better material. Refactoring is changing code without changing its effects. On the smallest scale, it's just rewording. So why learn about it formally when we all already do it every day? At age 1, we pick items up and put items down. You don't need a class on picking up boxes unless you work for UPS. And then more knowledge on body mechanics and how to find the center of gravity on oddball packages would mean a less painful workday. Now, I must preface the refactoring with safety. Refactoring Refactoring is not safe. Refactoring is unsafe. It cannot be done safely. Even Perl tidy can break code in very rare instances. I had a commit reverted by a front-end specialist. I had trimmed trailing white space that made a 1 pixel difference only in Internet Explorer. And it doesn't matter that that's trivial. I had caused an observable change that I did not intend to make. I was wrong. Testing is what makes refactoring safe enough to do at will. And testing means an automated test suite, not the ad hoc testing required in most schools. Oh, and source control, of course. Without testing, how will you know if you broke something in your refactoring? Without source control, how will you undo that breakage? If you're thinking backup, you don't want to talk to your backup guy. In a pinch, if somebody wants you to just look at the script for a minute, we'll just start minimal source control. It can be that simple. In a pinch, with hard-to-test web apps, I have been known to set up a mock database, get a bunch of URLs, run them through a script to remove the timestamps, take the MD5s and compare MD5s in between runs as assurance that I'm not changing behavior. But that is a kludge to achieve the absolute bare minimum of testing. The better coverage you have in your test suite, the less unsafe all your code changes are. So that was safety. Moving on. Code changes, I said. There are three kinds. I call them modes. Fix. Fixing something that was thought to work but does not function correctly. Add is adding new function. And refactoring is neutral between the two. You should be in a mode and know that you're in the mode. Be conscious of it. You don't have to finish fixing a bug before you refactor something that you need to refactor in there. But say, I'm clarifying this so that I can understand it, to fix it. Not, I'll just clean this up while I'm in here. And keep the modes clear in your commits too. Even if you're not doing test-driven development, add function, commit. Refactor, commit. Make it clear in your commit logs which one you're doing, your commit messages. You can squash before pushing your branch. Whether you are creating or altering code, you still need to decide how to express it. What influences those decisions? These are the factors that I could think of. The engineering forces that push your choice in how to say code. Maybe the optimized solution does not fit in well with the surrounding code. Or you know that the learning Perl book said, always write it this way, but you'd have to look that way up, and that would break your flow. My favorite is trying to code with the future in mind, but that flexible code is harder for a new reader to grasp. So for new code, I do think these are the forces. If you can think of others that are significant, email me. That's new code. For existing code, there is one more force. The code itself is a force affecting your decisions. Even if you wrote it 1 minute ago, there's inertia because you have to type any changes. That resistance is magnified if you didn't write it. Somebody else wrote it. I'd say that resistance is squared when you are not experienced and practiced at refactoring. And the resistance is cubed if you've got the sweats. That's no source control, no automated testing. We'll come back to this. The simplest refactorings are just changes of syntax. So you come to Perl, you've heard these dynamic languages all auto-extend their arrays. And referring to the array numerically gives the size of the array, which is one past the end of the array. So to add to the end of the array, you would write but there is a word for that. Push. And to get the socks back, you just use a -1 index. And then you declare to the array, oh, your size is one smaller than you thought it was. I've seen that all in real code. Those last two lines together, there's a word for that, pop. Now, in the initial forms, crossed out now, packed is repeated. Repetition is a code smell. The push and pop forms don't repeat. They are dry. But that's actually a minor point. Push and pop are more readable. Well, that's an arguable point. They're much more readable to all of us, I'm sure. But if you didn't know push and pop, you wouldn't understand it at all. So not more readable. My point is there is weight to, there's a word for that. Vocabulary is the most fundamental standard form. The language designer or library designer foresaw a common use case and named a method for your use. So using those words is the most reliable way to communicate. Usually shorter and faster code, too. That you can only use the words if you know the words. So you must learn your language and its major libraries. Since I learned the function first in Perl 6, I've used it every week in Perl 5. And I've been converting this to this since I learned about it last year at this conference. That has been in Perl since 5.12. There are mechanics that have been well researched to help manage large changes to minimize your untestable time. That's your danger time, the time where your tests are just broken. Why run them to say, is everything working? You know it's not working. Whole books are written on the fine details. In this example, we want to add a verb to the name final form. We want trigger final form. So you rename the sub, and your code is broken until you change every caller to have the same name, right? Now, if it's just one or two callers in the same file, we'll just rename the calls. No need to get complex about it. But if there are 20 callers across 12 different files, that's too long to leave things untestable. So you create a new sub with the original name that does nothing but call the new name with the same arguments and return its result. At this point, your code is unbroken. You can run tests again. You haven't achieved anything, but you can run tests again. And now you can change a few callers and run tests again, and change a whole file's worth from final form to trigger final form, and run your tests again, and then finish up and run your tests again, and then comment out the first 3 lines and run your tests again, and then delete the first 3 lines and run your test again, and that leaves exactly what you wanted with pretty much no untestable time. That's expressed a little differently in the book. There is a similar technique to temporarily wrap a subroutine to help debug it. I'm skipping it, but the slides have the details. Back to our forces. I assert that all these are the same thing. The top 5 are all readability? Well, they're all addressed by a focus on readability. Now, bottom right, boundary, scope, area of responsibility, that is a separate force that you must try to balance. Far left, performance, is also separate. That's not readability. But you should be ignoring performance. Quoting W.A. Wolf, more computing sins are committed in the name of efficiency, without necessarily achieving it, than for any other single reason, including blind stupidity. This is like telling people that dull knives cause most kitchen knife accidents. Safer is sharper. It is so completely counterintuitive that even when an expert says it to you, you go, no. I would need at least another hour to convince the entirety of the room that this is true. So please take it as a cue to discuss it with your peers and read up on the topic, because it is true. So all these forces, the top 5, are addressed with the correct focus. Like ease of change. We think that that comes from predicting future needs and coding for the form we think it's going to need. But really, what makes code hard to change is not that it was initially written without the future in mind. No, that slows us down hardly at all. What makes code hard to change is that it's not understandable. It takes you a long time to understand it to make the change. So, if you will target readability, you will actually find your code will be easier to change in the future than if you had targeted flexibility, than if you had focused on making it easy to change in the future. Readability. No. Readability. Naming is the best refactoring for readability. And I just realized 20 minutes ago that I was not mentioning this in any slide. So be aware that every time you inline code, like at the top, the sort is inlined, you are losing an opportunity to name the data or the action. Now, that needs 20 slides to be fair to how important it is. This is much more important than some of the other stuff I am going to cover in detail. I apologize. I spent too much time on the hillbilly joke. Picking your paradigm can improve readability across your whole code base. At an open source conference, a programmer asked me for a code review. It's not his actual code. It's very much like it. Very well-written procedural code. I noticed a cluster of subroutines that all have machine as the first parameter and a cluster around register. That suggests an object solution might be better. I noticed same verb, print and print, reset and reset, but with a noun as part of the subname to distinguish between printing on machine and printing register. That cinches it. That's textbook object-oriented design. It fits objects. He didn't know object-oriented programming at all. So I mocked up how it would look in OO. Let's focus on just the first line and its object version. So I got to remove machine from the method name and move from 3 parameters to 2. And yes, I know that behind the scenes it's really 3, but to any human reading it, it's 2. Every single subroutine in his system was shorter and more readable in method form. So we refactored just from experienced suspicion. But then we compared the readability of the 2, and he made his decision on whether OO was worth learning for his project. I want to convey a sense of how it all works together. So this example, about 10 minutes, my longest one. Getting the flow of it is much more important than the individual refactoring. So try to feel the flow. Now, we are going to be coding for the military of Bialya. Nobody? Small country, the continent of DC Comics. The code we're working on almost fits on one slide. We're calculating which soldier to promote and counting how many medals to order and making a list of transfers. We're iterating over not the soldiers themselves, but over their keys, their indexes. So I will be 0, 1, 2, till the end of the array. S will be the current soldier. If that soldier showed valor, he gets 2 medals. 2? Yes, I asked the general, she said 2. If no one has been selected for promotion yet, then this soldier will be the one promoted. That sounds wrong. Only one person gets promoted? And of all the soldiers who showed valor, we picked just the first one that happened to be in the array? That just can't be right. So what do? This really happened to me 3 weeks ago. I mean, not military, but I hit code and went, oh, this can't have been doing this. I have to tell someone. I have to be careful who I tell. What would you do? Think for 10 seconds. Well, we make a note of it somewhere to check later, investigate later, don't disrupt our flow. We make a bug ticket or quit in disgust. But what you don't do is try to fix something while you're refactoring. Even if you spot an obvious mistake, you do not try to fix while refactoring. All of our changes should be neutral changes. Okay, moving to the final block. I had to spill to the next slide. If the soldier wants a change of station, then add the index of the soldier to the list of transfers. I don't know why they want the index instead of the soldier itself. I've not read that far ahead in the code. So until we know, we must keep identical behavior. So the very first thing, I will change this if from a block to postfix form. And on the first slide, that inner if block also gets postfixed. And that is clearly better because it now fits on one slide. The push transfers at the bottom has nothing to do with the rest. They're just together for efficiency, so we don't have to loop twice. Efficiency, that sounds like performance. We're going to ignore that. Let's split the loop and see if that leads us anywhere. And yes, split loop is in the refactoring book. So I've duplicated the for block and the line defining $S. We handle medals and promote in the first loop and transfers in the second. Transfers doesn't have to be defined all the way up there. It's not needed till the second loop. So best practices tells us to move it. Let's focus on that second loop. S is only used once. Let's see how it looks without it. Well, that's not more readable. But when I close up the space, I can see a loop with nothing in it but a conditional push. A loop with nothing but a conditional push. There's a word for that. grep. So let's get it closer to grep by using the default topic instead of $I. Now again, by itself, that's a change towards less readability. But now we've got the reins in our teeth and we are heading for grep. We'll need room though. Now, grep looks like this. And I'm not ready for the target to affect anything yet. So the target will be a temporary variable. The source is from the for line. I ran out of my highlighting marker for a little while. Keys of soldiers. I see I'll need room for that big condition that's about to come, so I'll wrap to the next line. The condition is from up in that postfix postfix if. Done. Except that we populated temp and never use it for anything. What good is that at this point? Well, temp and transfers should always have identical contents at this point, right? Somebody nod their head. Thank you. So if my test suite needs a little help, I can assert here that they're equal and run the tests. Or I can run this code somewhere close to production and log the details of any disagreement until we're confident in our translation. The large microservice web apps use this strategy all the time. Then out with the old and in with the new. Meanwhile, back in that first loop, I notice that we don't use $I here anymore. We can directly iterate over the soldiers. Now we can split the loop again. We'll go faster this time. For the next trick, we'll need some high-speed helpers that come installed with Perl. Sum and first from listutil. Like the grep earlier, we're going to change the default topic. Change to the default topic. And there are several ways that I could recode the metals calculation as a pipeline. The first that comes to mind is a map of 2 if you have Valor and 0 if you don't, and just take the sum of that stream of numbers. Promote is a simple first on Valor. Remove all the extra space and align. Voila. Now comes the most important step, the one that's too often forgotten. After doing all that work, we must compare it to the original and decide, is it really better? Is it better enough to warrant change? It is to me, but I use map and grep and first all the time. This form is much more readable to me. If you hate the pipelines, fine. Just embrace this process. Let's catch our breath. That was dense. We'll end with something simpler. Lighthearted even. Maybe even not the end. So, on code fights, there was a problem factorial, which is where you multiply all the numbers from 1 to something all together and say what they all multiply together to be. And the problem was defined as we won't ask you to count more than 15. So that's the highest n that could get passed in to factorial. And it was a golf challenge, so you got graded on how few characters you could express your answer in. Now, I no longer like code golf. I used to be good at it. I don't like it. It fights with my readability reflexes. I like to look at the largest solution to see the approaches of new programmers or to see the work of other people that hate code golf. The largest on this one happened to be in Python. My wife doesn't code, and she laughed at this too. But how would you do it if you didn't know about recursion, or arrays, or lists, or loops? Or goto. This isn't from a bad coder. It's from someone new to coding. And by the way, that's not the actual code, and it wasn't actually factorial, because I would not do that to somebody. So how could we improve the readability of that? The crowd says, do it in Perl. I could write this in Perl. It would look just as bad. So I would tell him to line it up. If your coding standards do not allow you to take a form that is more readable, you should think about that coding standard. Make the engineering trade-off. Give it some thought. I'd point out that his variables are only used once and could be inlined. And I'd give him a simple lesson in Python lists, which is the same thing as Perl arrays. Notice that in the last two steps, I was targeting readability, but I got better performance as part of the change. I was never thinking of performance. Now, to go to this form, which is the way most programmers would express it if they're not in class requiring recursion, for this, you need to add in concepts of loops, loop variables, ranges, identity value, and accumulation. These are notions that programmer did not have. My brain is under the influence of Perl 6's auto-caching, lazy infinite lists. So my Python version looks like that, which is incredibly performant, but less readable. So I would actually change it back to that. No, I wouldn't. There's a word for that. Since Python 2.6, it's in the standard math library. Just import it. So I just said, you need the basics to get here from where he started. It's really till Q&A. Okay. It scared me. You need the basics to get from where he was to here. Loops, loop vars, ranges, identity value, accumulation. I bet you're all very skilled in thinking in those terms. You don't even think about thinking in those terms. It's basic programming. But if you are not skilled with functional thinking and object thinking, then you have a cognitive blind spot while you are coding that makes as big a difference in your code as from here to here. These final points I could not fit in anywhere, but I really need to say them. First, great books aren't born from great writing. They come from great rewriting, and lots of it. 2, there are coding hats and editing hats. And like the modes we talked about earlier, you would do well to be deliberate about which hat you're wearing in a particular moment of coding. 3, in my era, in my training era, I should say, my schooling, there was no concept of a readable code. First, you made your code work. Then you made it faster and smaller. And then, because it would always be unreadable after you made it faster and smaller, you had to thoroughly document it in English. All modern documentation practices were born from that era, that impulse of, it's going to be awful, you have to write it in English again. Most are still stuck in that wrong direction. When you study readability more deeply than we've had time to here, you'll find that you're writing less documentation in English, but the sum total of your code and that documentation is much more understandable. 4, your next steps in refactoring should not be to go read all the books on refactoring, or even to study this talk. Instead, practice daily at seeing what the code looks like this versus like that. Get fluid at the process. Get it in your fingers. And then start learning specific refactorings and add them to the mix. What questions do you have?
Looking at some code, you're refactoring it, you're deep into the refactor, and you find just a very small bug that you know is not going to break anything. Just humor me. Assume that you really know it. So would you go ahead and finish the refactor? Would you stash it, fix the bug, and then refactor? Would it depend on maybe whether or not you fix the bug would affect the refactor?
So the question is...
Or would you just do it in the refactor? And I know the answer to that one. So
Yeah. The question is, knowing that we don't just do it in the refactor, what do you do if you're in a big refactor and you find a tiny bug that you could just fix? Do you write the fix and stash it? Do you make a note somewhere? And my answer is, it really depends on your personal development process. If you are really good with Git and it's going to end up being the same in your commit logs, then I guess it's okay to write it, stash it, that kind of thing. Myself, I'm not quite that confident, and I make notes. But as you say, you never fix it. You want that distinction in your commit logs and in your brain. Absolutely. Yes, sir. Yes, he says he adds to that, git commit -p is your friend. That's what lets you see the pieces of what you're submitting, of what you're committing, and select them selectively. But with the size that was implied by his question, I wouldn't be confident when I started it that it was going to be discrete. Well, I guess you can always split them. I need to do more Git.
Along with that, git add -p.
And he reminds me of git add -p. What else? Yes, sir.
So I'm curious, describe your experience. What is the most you have shrunk the code base with refactor versus bug fixing or any other details like that?
What is the most I've ever shrunk a code base by refactoring? Well, I can't answer that in this instant. I will say that most the most severe refactoring reductions I've ever seen is where I see stuff that has been, there's a word for that, like a complete recursive search down the disk and you just put in file find, or you're doing a ton of regular expression stuff to parse HTML and you put in HTML tree, what is it, tree builder. But I do have a story for not on camera about a Atlanta programmer who took a report from 4 hours to under a minute last month during using nothing but refactoring, and it was all in Bash. It's amazing. Anyway, I hope that partially answers it. Maybe I'll have a better answer for you later in the conference. Yes, sir.
I've read a number of articles that use the word refactoring to talk about changes in the object hierarchy of a system, so more design level changes. Could you say a little bit on refactoring as you've been describing here with respect to design changes as opposed to implementation changes?
Okay. The question is, I skipped all the stuff that's at a slightly higher level. On standards, I was talking about like vocabulary and then idiom and then patterns. So that's more in the pattern realm. You could certainly do refactorings to bigger concepts and bigger conceptual constructions. Ooh, that's terrible. And I don't cover it. The reason I don't cover it is the books cover it, and the books put too much emphasis from my taste on it. There is a ton of focus. There's even a book. There's like, the refactorings book, and there's a refactorings to patterns book. And because I don't work primarily in OO, I'm a very multi-paradigm. I start in procedural, and then I start hoisting to objects where I see it's appropriate, and I start shifting things to functions where I find it's appropriate. To have such an intense focus on the object forms was off-putting to me and made me think that, it's part of what led to this talk, because the people that are working in primarily a procedural world need more information. So I'm sorry that, but that's a pointer to the right place, because the original book that was in Java has November it came out again. The second edition is all in JavaScript, and that's not nearly as far to row. And maybe one day we'll have one in Perl. Sorry, I saw a question over here. Was it you? It was you. Go ahead.
All right. You mentioned that readability is subjective. It depends on the vocabulary of the reader, for instance.
Mm-hmm.
And we have large code base and a large team. You're writing for a diverse audience.
Uh-huh.
How do you address that?
So how do you address the fact that you have a diverse audience and not everybody has the same reading level, same vocabulary, the same comfort level with every code construct? I had to leave out a huge chunk that I wanted to do on this dilemma that, and it's certainly true, it's easily expressed across teams. I expressed it at Future. When you're writing, like English, the key thing is who's your audience. Everybody will, that's common. Well, who's your audience when you're coding? Your maintenance programmer. And ignoring for a moment that 80% of the time you are the maintenance programmer, but remembering that there's an old adage of always code as if your maintenance programmer is a violent psychopath who knows your home address. So with that in mind, the original subtitle of this talk was Coding for Axe Murderers. So with all that said, I arrived at this, and I cut it because I'm not sure yet, but this is my insight that I'm hoping people can help me bear out. Your coding standards are your opportunity to describe your maintenance programmer. If you decide as a group, as a team, as a company, that we don't do map and grep here because we can't rely on hiring people in, we're a college or whatever, that can understand that level of sophistication, you put that in the standard and you don't have it in your code. And if on the other hand, that's something that you want your people to be using, or you want to be using if you're a one-man shop, but you need to pay attention to the maintenance programmer aspect, then you put that in your coding standard. This is okay. It's not just about how many spaces are we going to put in and whether we use tabs. It's opportunity for information that can be used during the hiring process to say this person does or doesn't have a comfort level with the code base they're about to tackle. So I hope that completely injected new idea into your head, and maybe it's applicable to your case. What else? Randall. Our author of many Perl books, Randall Schwartz, is reminding me that if you don't know map and grep, he can recommend some good books.
Or just buy him some drinks.
Or just buy him some drinks. He'll tell you, he'll instruct you person to person. Yes, sir.
Well, you have talked about running tests as you're refactoring, and I know almost all companies have tons and tons of tests, but imagine a fictional company in which they didn't have very many tests. What advice do you have for refactoring in that kind of case?
Okay, the question is, if you work for the one or two companies in the whole world that don't have complete test coverage, what's my recommendation? And that's a really, really good question. The first time I gave this, even though it was completely incoherent, the coherent question that came out is, testing's so important, I'm not doing it, how do I do it? And I really wanted to put in slides to skip over, but that you could refer back to of like, this is like the quickest way to get in, but I have not had time to do that. And every time I say I'll add them to the slides later, I haven't. So let me say on camera, there is a book, Perl Testing, Chromatic and Ian Stewart maybe, that is still available, and it's small, but it covers the basics. And so that's it technically. It'll give you what you need technically. As far as getting it into your company, we have had some stories about being sneaky. The general strategy is don't tell anybody you're doing it. Just write a test for yourself, and it'll help. So that's the start. Just one on something you're working on. Then you add some, and you still don't tell people. And then after you're adding enough that it has started to catch your bugs, you still don't tell anybody. But you commit it and make it part of the code base, and you start running it on other developers' commits. And then when you tell them, when you report the bug to them in the commit that they just made, maybe even do continual testing, have something email you, somebody did a commit, it didn't pass your test. When you bring it to them and say, oh, by the way, the test suite that I'm using myself did this. And either they will say, well, let me use that, or sometime later, they will want to run it themselves. And that's as far as I've gotten with the stories and the mentality of it. But at the end, it's a big win. Everybody will accept it especially when it's optional for them. And then when it's fixing a lot of bugs and catching a lot of errors, then you can make it mandatory. Anything else? I just got the signal. We'll have to wait for the hallway or email. Thanks.